So welcome all, and today we are learning statistics. And statistics is nothing but measures of tendency or dispersion. And now we are going to learn mean, median, mode, and variance and standard deviation. I hope you've seen first few minutes of video where they're gonna having what is mean, median, mode, variance, and standard deviation, how it is used in Python. And also I told only group ungrouped data, and soon we'll learn about grouped data also. So now we are going to see what is mean, what is mean average, and handling what is mean means mean is average, to find average, and we are using the main for Python to mainly for handling missing values. And we'll see how ML is used in real world. Suppose we'll take one example, guys. We'll take one example, and with that example we'll do what, how, and why it is used. Suppose some students' ages are missing in the data set, so we replace missing values with the average age. So you see why it is useful. You can ask now why mode is used, why mean, mode, medium are used in ML. So it is used for handling missing values, data cleaning, improve model training. So let's start doing code, and I hope you're also doing code, and please try with me. And without practicing we can't learn in theoretically. Once I learned theoretically a lot, but now it's not useful. So okay, let's start. So let's start. We'll start with importing pandas. Sorry. So we'll import sklearn from libraries. Simple. Sorry, we need to give capital for S. So I'm taking my own data. So this is my own data. I'm taking own data because I'm filling the gaps where we have none in our data. So basically we use mean, median, mode for none values only, to fill the none values, handling the missing data. So I mentioned handling the missing data. So let's see how we handle this missing data by using the mean. So I took my own data here. So df is equal to, now we are changing into df, data frame. So now we are taking strategy. Strategy is equal to, first we'll do with mean. Okay. Next we'll take df of column age. I think we need to give this. Computer dot fit transform of df age print df. That's it, guys, we're done. So let's run this program. I think it's correct. So let's see. So we got output. Yeah, I give 22, 25. It took their own like a default value. It took default value, means it took 25, and in 6th place it took 25. Okay, it took default value. So this is where we use mean in our machine learning or Python. So in Python only we will use to handle the missing values for data cleaning. So it will improve the model training and the model efficiency and model accuracy also. So where we have missing values means it will disturb the program. So we using mean for this, and also we same strategy for mean, medium, mode. Just we took here a strategy, right? So in that place we need to change mean, medium, mode. So I'll not code, I'll just show how we are using that one. So let's see, 1 second, guys. So I told you, right, I finished mean, mode, medium. Okay, so this is medium, which handles the outliers. Outliers, we know that the very long values, very far values, different values from other values. So in real time, we'll use in machine learning like house price prediction data set often contains extreme values, right? So house value, house price is always increasing, so it often contains extra, means more content, right? More values. So we use to reverse against outliers and also better than mean when data is big. When data is big means it is better than the mean, means who will do the process who will do the process sum of the values by total number of values, it will get large number of value, right? Because of house price prediction have the extreme values, so the mean becomes very large but medium stays realistic. So this is the code where mean and medium mode are same only. It's just we need to take our own data, or we can also import from the any import any data sets. It's not a matter. So I took on my own data for sample. So the same process we are doing. We are taking imputer. We are importing simple imputer, and just I changed mean, medium. So same process. So I got none. I handled none with the value of 29,000. You know what? Here there is something like big value which we can't compare with others, because they are in thousands and this is in lakhs, like nearly 10 lakhs. So these are 1,000 and we can't compare also. So this is the outlier. This is the outlier. So this is the Python program for medium, and mode also same, but it is very useful for filling categorical data. So it uses in real world machine learning for missing gender, like a none value of genders and city and department values or anything in categorical data. So here simply we are importing null values, and sorry, here we are importing pandas, and then we are importing impute and simple imputer, and we took gender, male, female, male, and here none and male, and then we took data frame and we are using simple imputer, and then we took most frequent repeated numbers, means more frequent repeated numbers means it's not in mode. So df is equal to gender, and same, and here we got 1 second. So there is one mistake in mode. I think you will find out, and you will write code in comment section. So variance is the one of the topic we need to talk more. So in variance there is a future selection, and in real time we'll use like for removing futures that never change, means we know what is the variance. Again we need to talk about it, and why it is useful means low variance futures contains little information, right? So if we take low variance means if the data points are very far from the mean values, means it will contain only less information, right? So it will reduce unnecessary columns and also improves model performance. So this is about the variance future selection. So we should talk about this program. Definitely we are talking about this program. So now we are talking about varying. So variance is one of the important and one of the major topic in machine learning. So where we using this code, we use this code, right? This code variance threshold, where variance threshold is used to remove the columns that have no variations, and it means all are same. If they all the values are same, means it is not useful, right? So it will remove the columns that have no variations. So in machine learning, a column that never changes doesn't help the model training on model learning, right? If the values are changing, means the model will learn. If the values are not changing, it is like a static, means it is not change, it is not learn anything, and accuracy of the model also very less. So in data set, we took one data set here. We took one data set where A, B, C values, and in A value there is some value, in A data there is some values, and B data there is some values, and C data there are some values. Means A have all ones, and B have 1 to 5, and C has 5 to 9. So we know that what is the variance formula. Variance formula is like a sigma of square root 2 is equal to summation of x minus mu, mu means mean, of square of 2 by n. Okay, means x is equal to data point, mu is equal to mu, and also n is equal to total values. So okay, formula is all set. And then now what we are doing means, first we took column A. We need to calculate column A. Means every value equals to the mean, right? We need to take what is the mean of 1. The mean of 1 is mean of column A is like 1. So every value equals to the mean. Means we are taking here x minus mu. X minus mu means x minus mean. Means 1 minus 1, 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 because x is equal to 1 and mu mean is equal to also 1. So we are doing subtraction. So here we got all 0. So we got variance is 0. So no information. Variance 0 means no information, right? So we take column B. In column B we have 1, 2, 3, 4, 5. Mean is equal to 3. If we do mean for this means mean is equal to 3. We know that mean formula. Sum of all numbers by total numbers. So values are changing. Means we got mean 3. So the values are changing. So it comes like the variance. If you calculate means, if you calculate with the variance formula means the values will come like a greater than 0. It will come greater than 0 means it has some information, useful information. So column C we have 5, 6, 7, 8, 9. It means mean 7. Mean is equal to 7. So if the mean is equal to 7 means the values are again changing now. So the value the variance will come like greater than 0 only. So it has some information, some useful information. And step 3, create variance threshold. After that, what we done in step 1, we took data set A, B, C column and we done mean, and with that mean we separated values minus mean, and then what we done, we added, like we implemented in variance formula, and then we got variance. If the variance is 0 means it is not, no information means not useful. If something changes, the values are changing means okay, variance is greater than 0. So now we need to create variance threshold. So here we'll took selector is equal to variance threshold. Threshold is equal to 0. Here what we are doing means we are removing column. We are removing column where column has variance is 0. Means we need to apply it. So here we given we given threshold is equal to 0. We need to remove it. So we need to apply x is equal to new is equal to selector dot fit transform x. So what we are doing here, we are applying. We got A is equal to 0, variance is 0, B is equal to greater than 0, where some information it has, C is equal to greater than 0, some information it has. So column A is removed, and then output like a print x underscore of new. Means here the column A is gone because there is no information. So we took only B column and C column. So this is the output. So what we are doing here means we are taking variance, we are taking useful information. We are removing the information which is not useful, which is no information means we are removing the data, and we are taking what the data we need, what the data we need to put in our data set. We are taking that one. Which data is useful, we are taking that one. So here A has 0 variance, so it is not useful. So we took B and C. Likewise in machine learning also, if the data, if all the data, we know that computer uses only numerical data or sometimes binary data. So there, if the variance is very low or 0 means it will remove that data, and it will take only useful and informational data. Likewise, so this is the program about variance. So now we'll see standard deviation also. So I hope you understand what is variance and how it is useful in data set or ML machine learning. So now we'll see what is standard deviation, which is future scaling. So in real world ML use, most ML algorithm need futures on similar scales, right? So why ML uses it? Why standard deviation uses in a machine learning? So it used in a logistic regression, it used in a SVM support vector machine, it used in KNN, K neural network, and next it used in neural networks. So this is the topics we need to discuss further. So we'll discuss in next videos. So this is the program, Python program for the standard scaler. It is all same only. First I imported such standard scaler, and then I took my own data, and then standard scaler, and same like how we done mean mode, same like that only. So yeah, I told you now, standard scaler means it will be square root of variance. So it will be square root of variance. How much the variance will come in? So it will be square root of variance. So like this. So Yeah. So this is all course about mean, medium, mode, and also variance, standard deviation. So again we will see from start. So it is the statistic, and it is used for mathematically, and measures of tendency, it is the measures of tendency and dispersion, and we are seeing a mean, mode, median, and also variance, standard deviation. We know that mean is